Everybody, I am here to talk to you guys about high voltage systems. So the last lecture that you should have watched was Mr. O'Connell's high voltage safety systems. There's a lot of things that are explained in that video, so if you haven't watched that one yet, make sure you go back and watch that one before you go and watch this lecture. So in case you haven't already done it, I would also like you to look at the presentation prior to, just sort of breeze through. I'm going to go through and explain a couple of things, so if you want to jot down anything extra, I'm just going to sort of elaborate in a couple of areas and talk about some testing techniques. So we can go ahead and get started here. As I mentioned, we're talking about working with high voltage. So Mr. O'Connell, again, already talked about how to use gloves and how to safely power down a vehicle. What we're going to talk about here is identify the different types of categories when you are, after you power down a vehicle, checking for that high voltage. What if there is still high voltage there, maybe something shorted out or a contactor got welded shut, and you see high voltage. That's why we check after we power down, because if I just power down and assume it's go ahead to work on it, then I am not going to be a happy camper. So we're going to talk about some of the testing equipment. We're also going to get into what type of DVOMs we should be using. Talk about isolation faults and how to perform an insulation test. So we know what to do when we do come across one of those codes. It's actually a really frequent problem that I have diagnosed in many vehicles, and I'm sure will continue to happen. So we'll go ahead and get into that. First things first, just a quick review. Hopefully you're following along with me. If you've got two screens, then perfect. If not, you can go ahead and try to listen while you look at the presentation. Maybe go back and forth. Right now we're trying to figure things out still. Hopefully in the near future I can learn how to mirror my presentation on there and sort of go back and forth. So if I'm going to draw something for you, then we can go back to the PowerPoint and all that good stuff. So for right now, just bear with me here. So the next slide is what to look for. We've talked about this a number of times, so just sort of to reiterate, we're looking at conduit colors, and when I say conduit, I'm referring to the wrapping around your wiring harness. Most of the OEMs go ahead and use a plastic conduit with electrical tape. While we're looking at that, the colors, which I believe we talked back in chapter 2 about, at least in the homework questions. As far as wire colors go, if we're dealing with a system that is 36 volts, we are dealing with voltages while the vehicle is running a little bit higher. It's charging system voltage, right? So those systems are going to be blue or yellow. Older systems were yellow. They decided, oh, that's right, we use that for SRS. Not a good idea. So then they go back to blue. So for the most part, your 36 volt / 42 volt systems are going to be a blue color. And just to sort of reiterate from last time, if you weren't there, or if you didn't catch it, that charging system voltage is very similar to your alternator, right? Our low voltage system, we know that the battery is a 12.6 volt battery, but when your vehicle is running, your alternator runs at a higher voltage, right? So we're generally going to be around 14-ish volts as far as charging system voltage goes, or vehicle on voltage. So that's where the 42 volt comes into play. So just sort of clearing some of that stuff up, because I know there was some confusion about that. As I mentioned though, those are blue. When we start getting into the higher voltage systems, 144 volts and up, we get into the orange conduit, meaning back off, right? Unless you've got proper testing equipment and you know what the heck you're doing. I believe in your chapter quiz questions, it does ask about it. I believe in your PowerPoint, I've got it as a shock hazard. Your shock hazard color is going to be considered the orange. You may feel it at less than 144, but 144 is going to be our limit for the orange conduit. So moving along here, naturally it's sort of gone and freaked out on me. Uh-oh. Hopefully I can edit this out. Let's go back here. Sorry about that. And whoa. And sorry about that. So, technology. First thing I want to talk about is category ratings, which is our next slide. So now that we know the wire colors for the different types of voltages, you should be able to identify around what voltage you are working on. You need to know what type of test equipment you're going to need in order to work on that system. You can't just use your $5 meter or free meter from Harbor Freight if you got the coupon. It's definitely not going to be adequate for high voltage systems. How do you know your meter is adequate for high voltage systems? That's where category ratings come in. So the category ratings, aka CAT, whatever number is after, is referring to the level of energy that system can take before it starts to break down. So your meter actually has two ratings. It's got a category rating, and then it's going to be followed by a voltage. Those are two separate ratings. The voltage next to the category rating is referring to transient voltages or voltage spikes. So if it's rated at 1,000 volts or 600 volts, those are the types of systems that you can work on. But the category rating is really referring to what energy level you plan on testing. And really this gets down into, are you working on a power pole or anything like that? Sorry, I paused there. What you're working on, and it's a lot of times not really referring to automotive. It's energy levels, amperage spikes, and things like that. If for working on hybrids, the minimum that you're going to want to use is going to be your category 3. You don't necessarily need a category 4. However, you can use one. If it's already rated for that, it's no problem. But you're going to want at least category 3 if you're working on high voltage systems. So right there on your slide, I've got a quote from the Fluke manufacturer themselves for the meter as they sort of explain it. They say the higher CAT number, or the higher the CAT number refers to an electrical environment with higher power available and higher energy transients. So not just voltage transients, we're also talking amperage transients or power transients and stuff like that too. So we're not looking at just one. Moving along here, on the picture in your slide, I've got a close-up. It's showing in between your voltage terminal and the common terminal. It's saying that it's either going to be considered a category 3 at 1,000 volts, remember category being the energy level, or a category 4 at 600 volts. Pay attention to what you're using. Just because it's a higher voltage doesn't necessarily mean it's a higher category, so on and so forth. So not only is your meter rated at a particular category level, your leads are also, and that could be weak links. So if you're using cheese ball leads from your Harbor Freight meter and you manage to make that happen, you could get hurt. So not only are you going to want to use the appropriate category for your meter, you're also going to want to use your appropriate category for the leads as well. And if you take a closer look to the picture that I gave you guys, the bottom picture down here actually shows the meter the meter leads with little caps on the tip. So you might have seen that before. Lots of the meters from the tool cage probably are missing those. The higher category meters will come with them. So not all meters necessarily come with them. Those caps are not just an inconvenience or to look a certain way, or necessarily to just protect the leads from damage. It's actually going to provide a higher protection for you, the user. So if you are testing high voltage systems, you need to make sure you leave those caps on, or else the category level and the voltage spike level actually is not what it's rated at, and will be lower, and you could potentially hurt yourself. So make sure you keep those caps on. It's pretty important. And we done did it again. For crying out loud. Okay, so moving along here, we've got testing our meter leads. So once you have found your appropriate meter, your appropriate category leads, and appropriate voltage leads, it's time to test them. So we want to make sure that they actually work okay. You don't want to go through and test something for an isolation fault and you get a false positive or a false negative, and you're like, oh, okay, things are good, or maybe things aren't good, and it's really not because of the equipment, but more of your leads and the meter itself. So a couple of tests you can do. First, an easy one is a nice visual test, and I've got a couple of pictures on the next slide. We're looking for bent leads or bent probes. We're looking for any chafing or burning on the leads, and we're also checking for cracking because we don't want any shorts. That would be sort of a bummer for you if you're working on a high voltage system. When you are checking for cracks, you may not notice it with the lead straight, but if you go ahead and you sort of bend it and take a close look, if the leads are old or have been exposed to lots of temperature changes, they can get brittle, and when they bend, they'll show the cracks. So that's one technique sort of to look at for that type of stuff. Then you're going to go ahead and actually ohm test them. So you'll go ahead and plug your leads in the appropriate areas for ohm testing. You'll go ahead and set your meter to ohm setting, and then you're just going to touch the leads together. And you want to make sure that they don't have any excessive resistance, or you want to make sure that they aren't open, because that will definitely change your test results when you are actually testing the equipment for isolation faults and stuff like that. So you're going to go ahead and touch them together. I shouldn't see any resistance. And if I do, then I've got an issue. Or if it shows OL, then that's another issue, right? And they're actually broken inside. They haven't opened, so, or your meter hasn't opened. So you'd have to diagnose that from there. Once you have found your meter leads visually okay, and you've tested them and they come out good, then you can go ahead and use your meter. So a couple of good visuals on the pictures that I gave you guys in your slides. We've got a common problem where the lead head will actually sort of start to disconnect from the meter lead wire. We've got hooks that get bent and melted, and you're going to need to test all of the equipment you're using. So if you're using alligator clips, if you're using any of the test hooks, any of that stuff, you need to make sure that you're testing it before you actually go to perform the test. There's also a really good picture of a melted wire or a chafed wire for the lead as well. So that common problem and easily overlooked. Next thing is to set your meter to voltage, and you're going to go ahead and after you power down, how do you check for that voltage afterward? Which I have had issues that voltage was actually present after I powered down. We'll get into that when we get into our lab and we do our demonstrations. But that's something you must do every single time if you don't want to hurt yourself. You need to make sure, because it's just that one-off chance that you get a contactor that shorted or welded closed and something was supposed to shut off and it didn't. So a couple of areas that you can check. So you're going to take your meter with your appropriate class gloves, right? You are going to set your meter to your voltage setting. And there's a couple different areas that you can check. So you can check for voltage on a positive and a negative, again, because we've got floating grounds here. Wire. You can check your high voltage capacitors. You can check the motor generators themselves coming from the power inverter. You can check voltage coming into the power inverter, and then as well as coming out of the high voltage battery past the contactors, because they should have opened up. I wish I could tell you that everything is always going to be in the same place. So just for your capacitors, it's always under hood. No. Some vehicles, things are going to be located in different spots. So I go for whatever's easiest. If it's going to take me a half an hour or 45 minutes to get to my capacitors, I'm probably not checking that area, and I will check two other areas. I like to do a solid check on two separate areas in the vehicle just to make sure everything's all good. But obviously, if I don't have any voltage coming out of my high voltage contactors, I shouldn't up front, but again, those capacitors. So you want to make a couple of different areas checks. Around where your power inverter is always good, or somewhere after the power inverter. Because if your high voltage capacitors, which are located generally in your power inverter or near the power inverter, are not discharged yet, then you can see what voltage is coming out of that as well. Obviously, if you have high voltage still after you have powered down, you've got an issue, and you're going to need to diagnose that and what's not shutting off. If you have confirmed no high voltage, then you're good to go. I just would like to remind everybody that you are not generally going to be digging into things or working on things or taking things apart with the system ever live. No dealer technicians do that. Nobody at hybrid or EV shops really work on the system like that live. It's very rare. It's not necessary. So most of the time you are going to power down, disconnect high voltage, and then work on the vehicle after it's safe. Or if you need to do tests with the vehicle live, it's usually going to be with the scan tool and you're not digging into things. But we'll talk more about that as we go along. And next I'd like to get into loss of insulation, but I'm probably going to go ahead and make a separate video for that. So I'll just have a couple separate links, so not everything's linked in one big old video.